In this video, we are going to solve problems based on impulse. So in the first problem, we have got a 325-gram ball hits the ground with 3 meter per second directed vertically downward. So let's just draw it. Ground, a ball which hits the ground with 3 meter per second, which is vertically downwards. Then it bounces off the ground with a speed of 2 meter per second directed vertically upwards. So that's what we have drawn in the diagram. It's asking what is the impulse received by the ball. So we'll write impulse equal, we'll use the formula impulse equal change in momentum, which is Pf minus Pi, and we know momentum is mvf minus mvi. So I'm just taking mass common because mass is coming in both the expressions, so we can write m bracket vf minus vi. The mass is given as 325 gram, which will convert to kgs, 325 over 1000, which is 0.325 kg. And vi, now focus on the diagram. Vi, I've taken it as negative 3 meter per second because it's going downwards. And vf is positive 2 meter per second, which is upwards because it's going upwards, so we take it as positive. This is very important, the signs for velocities. It's velocity which is coming in the formula. So we need to know, should I put negative or not? So now we will put that in the formula. Vf is 2 minus bracket, then again minus 3 will put in the bracket and bracket close, multiply by 0.325, which is the mass. Calculate it, you will get it as 1.625, and the unit for impulse is kg meter per second. Next problem, a 49.5 gram tennis ball traveling at 18.2 meter per second is hit by a tennis racket which applies a force of 25.7 Newton to the ball for 16.3 milliseconds. So the mass is 49.5 gram, which will convert into kgs by dividing by 1000. Then vi, the initial velocity is 18.2 meter per second. The force is 25.7 Newton. And the time is given as 16.3 ms. What is this ms? It's milliseconds. So we need to convert that because we want it in seconds. So we need to divide the number by 1000. It will become 0.0163 seconds. Now impulse has two formulas, so we need to decide which one to use here to get the answer. So if we see the second formula, which is force multiplied by time, we have got both the numbers here, so we can use that, substitute the numbers and get the answer as 0.4189 Newton second, which we can round off. Next question, impulse from the graph. So here it says when a boy hits a 46 gram golf ball, mass is given as 46 gram, we convert that into kgs. The impact force varies with time as shown in the graph below. So there's a graph given to us. Find the impulse experienced if the impact time is 0.5 seconds. So we'll write impulse equal area under graph, which is a triangle here. And for triangle, the area is half base times height. The base here is 0.5 and the height here is 15. We can read both of these numbers from the graph. So we substitute that, calculate it to get it as 3.75 Newton second. Again, don't forget to put the unit. Impulse can have two units, kg meter per second or Newton second. Both are correct. Next it says find the speed of the ball when it leaves the club, assuming it was at rest before being hit. So it was at rest before being hit, that means that's vi, and they're asking us what is final velocity. So we use the formula impulse equal delta p because it's talking about velocity and p has velocity in its formula. So we'll use that, mvf minus mvi. 3.75 is the impulse, the mass is 0.046, vf we don't know, minus 0.046 times 0 because initial velocity is 0. Anything multiplied by 0 is 0. So our equation reduces, 3.75 equals 0.046 vf. We'll divide both the sides and we get the answer as 81.5 meter per second. Then it's asking average force exerted by the ball during impact. So we'll write impulse equal F delta T. because it's talking about force, so we have to use the formula for impulse in which it has force, which is F delta T. We have got impulse as 3.75 equal force we don't know, the time we know from the graph 0.5, then we divide both the sides by 0.5 and we get the force as 7.5 Newton.